Today we're going to talk about how to find coordinate points and the domain and range of a function just by looking at the graph of the function. To complete this problem, we'll look for points on the y-axis that correspond with points on the x-axis. Then, to find domain and range, we'll look for all x and y values that the function attains. And in this particular problem, we've been asked to find f of 1 and f of 5, as well as the domain and range based on the graph of the function. So the first part, finding f of 1 and f of 5, is just interpreting values from the graph. When we're asked to find f of 1 and f of 5, all we'll be doing is looking at the y value for the function when x is equal to 1 and 5. So for example, f of 1, we can locate the point on the x-axis where x equals 1. So that's this point right here. And to find the corresponding y value, we just go up and meet the graph wherever it is, and we see that we get to the graph at this point. If we go over to the left, we see that we hit the y-axis at 3 right here. So we know that f of 1 is equal to 3. And this basically means that we have the coordinate point 1, 3, where x is 1 and y is 3, on the graph of our function. So same thing here with f of 5. We find the point along the x-axis where x is equal to 5, and we go down in this case to meet our function. So we come down here to meet our function, and if we come back over to the y-axis, we see that we'll run into approximately -2. I haven't drawn this graph perfectly, but the idea is we run into -2 here on the y-axis, so we get -2 for f of 5. And that tells us that we have a coordinate point on the graph of our function of 5, -2. That means that when we plug in 5 to our function, we'll get back a value of -2, or when we plug in 1 to our function, we'll get back a value of 3. So now when we talk about domain and range, we want to define that domain is all of the x values for which the function is defined. So we just need to give a list or a range of all x values that this function could possibly attain. And if we look at the graph of this function here, we can see that the smallest x value it attains is x equals 0, right? There are no x values to the left of this point for which the function is defined. This is where the function starts on the left-hand side. It ends here on the right-hand side. So we know that the domain runs from this point all the way to this point, and the left-hand side here is equal to 0. The right-hand side is equal to 7. So we can say that the domain is x greater than or equal to 0 and less than or equal to 7. We can also write that as, in square brackets like this, 0, 7. Now the range is the corresponding set of y values that the function can attain based on the domain that we've already defined. So on this domain here from 0 to 7, which y values can the function attain? Well, we can see here that, and we'll use a different color, we can see here that the highest y value is at this point here, and that the lowest y value is at this point here. So we know that our range runs from this point to this point, and that's the range. The y-coordinate at the top of our range here is 4, and at the bottom it's -2. So we can say that the range is y greater than or equal to -2 and less than or equal to 4, and again we can write that as -2 to 4. And that's all there is to it. That's how you can find coordinate points or values from your function and domain and range from your function just by looking at the graph of the function, even when you don't have the function's equation.